Okay, so just two more problems to do, number 87 and number 123. So, in problem number 87, it is the same as problem number 85, but we have a different function. So we have f of x equals 1 over x plus 3. So f of x plus delta x, we just replace x with x plus delta x. Okay, so this becomes, let's bring out this delta x right away. Right, so that this is the same thing as division by a fraction, so we multiply by the reciprocal, right? This allows us to focus on what's going on in this numerator and save the reasoning for the delta x until the end a little bit later. Okay, so we do our substitutions. The quantity of x plus delta x goes into the first term. The quantity of f of x goes into the second term. So let's try to simplify these, right? I have one quantity of x plus 3 as a factor in the denominator in the second term. I have one quantity of x plus delta x plus 3 in the denominator of the first term. So let's try to combine these two fractions together, right? That means that I need to multiply the top and the bottom of the first fraction by x plus 3, both in the top and the bottom. And I need, in the second fraction, I need to multiply by x plus delta x plus 3 in the top and the bottom. And that's what I do, right? So 1 times x plus 3 is x plus 3. 1 times x plus delta x plus 3 is this. Therefore, in the denominator, both will have factors of x plus 3 and x plus delta x plus 3. So they have a common denominator that can be shared between the two. And then I have this minus sign, right, that can be brought into the numerator of the second term. So then it becomes distributed, right, when I do my simplification. So this minus x plus delta x plus 3 becomes minus x minus delta x minus 3. I can just bring my x plus 3 over. So I have a quantity of x and negative x that cancel additively. I have a quantity of plus 3 and minus 3 that cancel additively. When all of those cancel, I'll be left with only one factor of a negative delta x left in the numerator, and that will go to 1. Or excuse me, that will cancel with this delta x that's out here, right? If I were to multiply this 1 over delta x into this, I would have a delta x on the bottom here, and that would cancel out with this, leaving me with a negative 1 in the numerator. So I have negative 1 over x plus 3 over x plus delta x plus 3. And this 1 over delta x was the only thing that was preventing us from doing direct substitution. That was the thing that would give us division by 0. So since it's now canceled, I can do my direct substitution. I can put in delta x equal to 0. There's nothing stopping me from doing so. So when I do that, I'm just left with negative 1 over x plus 3 quantity times x plus 3, the quantity of x plus 3. So that is equal to negative 1 over the quantity of x plus 3 squared. Let's just do number 123 one more time, real quick. So we said prove that the limit as delta x goes to 0 of 1 minus cosine of x over x equal to 0. Instead of bringing this limit all the way forward each time, I'll just look at what's inside the limit as an aside, right? So I say, well, let me do the form of the function, and I'll not consider its limit. I'll just consider the form of the function itself. So we said that if this was only a squared term, we would have a sine of x, and knowing that the limit as x goes to 0 of sine of x over x equals 1, then we could use that fact to find out what this limit would be. So in order to get this squared term, we can multiply the top and the bottom by 1 plus cosine of x, which would give us the difference of perfect squares. So when we distributed these two quantities together, we would get 1 minus cosine squared of x with a quantity of 1 plus cosine of x. And this is the same thing, and this is the same thing as sine squared of x. And sine squared of x is the same thing as sine of x times sine of x. I can segregate these two quantities by saying, all right, well, instead of writing sine of x squared, I'll write sine of x times sine of x. I can split the factors up between a fraction any way that I want. So I can say, hey, this is the same thing as sine of x over x times sine of x over 1 plus cosine of x. So when I take this and I say, hey, I want to find the limit, I know, hey, I manipulated this function and got it into this form. So I can say that the limit as x goes to 0 of 1 minus cosine of x over x is equal to the limit as x goes to 0 of sine of x over x times the limit of sine of x over 1 plus cosine of x. This I can use direct substitution. This I proved went to 1. So therefore I get 1 times 0, which is 0. And that is the end of the proof. And the end of our examples from section 1.3. If you have any other requests, please let me know, and I will do them.